So far we covered what is ECG. So introduction, just brief introduction. I didn't go ahead because if I wanted you to understand the basic. So we learned cardiac anatomy, cardiac electrophysiology, cardiac cycle, and then followed by the cardiac conduction system. Why it is very important? Once we go further, then you will come to know why it is very important. Now the next topic will start is action potential. When I learned, I found it absolutely boring. Nobody wants to learn, but I found this is the most important, one of the most important topic when you want to learn ECG. If you have basic fundamentals clear about action potential, it is very easy to understand the ECG also, ECG pharmacology also, cardiac pharmacology, where this action potential, your clarity about action potential will help you in pharmacological management also. So we will start. So action potential, myocardial cell, and action potential of pacemaker cell. Myocardial cell means cardiac myocyte, and pacemaker cell like sino, atrial node, AV node. So we will take one only, SA node, pacemaker cell depolarization. We will first take action potential of myocardial cell. Myocardial cell. There are 5 phases: phase 0, phase 1, phase 2, phase 3 and phase 4. So 0, 1, 2, 3, 4. So I will draw a diagram and then I will explain you. What happens? Ultimately, cardiac myocyte depolarization, how it takes place, from where it comes? It comes from the depolarization of the node, which we are going to take later, but nodes had depolarized. Now that depolarization waves, it is a wave, na? So that comes to the cardiac myocyte, and now cardiac myocyte, like I am talking about, this is mostly a ventricular myocyte and atrial myocyte. There are n number of action potential in the heart, and different level, the graph will definitely change, like atrial myocyte, ventricular myocyte. So we will take mainly ventricular myocyte and SA node only. So pacemaker, SA node, and this is cardiac myocyte. So see, what we call is a resting membrane potential, RMP, which is minus 90 millivolt. So action potential was I was talking about. So what is basically action potential? So this is a cardiac myocyte, and when it is charged, so resting, which is negative inside and positive outside, and when action potential takes place, there is a brief change in the voltage across the membrane, and what happens, how, and then there is a ion which enters inside these things. I am just randomly I am drawing just to make you understand. So there is a brief change when there is a depolarization. Action potential is nothing but depolarization, and repolarization is action potential. This is a brief change in potential. And movement of ions. What are the three important ions which takes part in the action potential? One is sodium, that is Na, one is calcium, and one is potassium. These are the ion. And how it moves? They move through the ion channels. So when the cell is at rest, the resting membrane potential is minus negative. So is fully polarized cell. Now what happens? There is something known as threshold potential. Threshold. So threshold, you know, when the cell has to undergo depolarization, it has to reach to the certain voltage. So that voltage, so that is minus 70 millivolt. So this is minus 90 and minus 70. So now from minus 90 to it's will there are very leaky sodium channel, leaky. So that trickles inside the cell. So it is positive, na? So positive means the voltage will go from minus 9 to minus 70, because positive ions are being added. So it will go from minus 90 to minus 70. This is threshold potential. As soon as reach to threshold potential, fast sodium channel opens. What happens? Fast sodium channels open. And sodium enters, and it comes to the plus 20 millivolt, almost. So starting it was 90, then it has with leaky sodium entry, it was minus 70, and suddenly at this threshold potential fast channel opened, and there is a gush of sodium inside the cell, and so the voltage become plus 20. So this is depolarization is over. So your depolarization part of the action potential is over. So this is phase 0. When the depolarization takes, it is known as phase 0, when the sodium fast channel enter. See how important it is. There are drugs which acts on this sodium channel. So if you know action potential well, your pharmacology or treatment of the patient becomes very easy. So there are drugs which blocks the sodium channel. So the action potential which will be delayed. So that will come when we pick a time, we talk about the cardiac pharmacology. But timing you remember that fast sodium channels have opened up and lot of sodium has entered inside. So the potential enters to 0.20, and at this point the sodium channel has closed. And immediately the potassium which is inside the cell. So see, one is sodium, one is potassium. We are talking about one is sodium, one is potassium. So potassium which goes out, when potassium, this is just open and potassium channel has just started opening, so it reach here. This is phase 1. So it is 0 millivolt. As soon as sodium closes, it reaches to the, and potassium channels open, it reaches to the phase 1. This is actually we call it a end of the, it is a junction of depolarization and repolarization. Or even you call is a now this is a phase 2. In what happens in phase 2? In phase 2, the calcium which enters in the cell, but at the same time potassium goes out of the cell. This is leaking out of the potassium, entry of the cell. Why calcium? Calcium is very important for cardiac contractility. When calcium enters, it causes sarcomeal calcium to come out, and then cardiac contraction or systole takes place. So calcium is an important part of cardiac contractility. This potassium is going out. So it is equal. So this becomes a plateau phase. So phase 2 becomes a plateau phase. Phase 2, plateau phase. So phase 2, because this remains here only, because one positive ion is coming, one positive is going away. What happens here? The calcium channel closes. When calcium channel closes, but potassium is continue to go out. So when now positive ions are going out, so ultimately it immediately comes down the voltage, and it will come to the resting membrane potential, which has been around 90 millivolt. First, sodium has entered, sodium has closed. Here it is reached to the plus 20. It has come to 0. Again it maintained here, because calcium are coming in for the contraction of the cardiac contractility. Ultimately it will stimulate the sarcomeric calcium, and potassium is out. So this is a balance. So this phase is a plateau phase. What happens here? Here the calcium channel closes. Here the calcium channel closes, but potassium goes out. So voltage comes to minus millivolt, and this is phase 3, and this is phase 4. This is phase 4. So this is phase 4, phase 0, 1, 2, 3, and this is 4. What happens at phase 4? Phase 4. This is phase 4. Now you will tell me, sir, this potassium is going out, and then next cycle will take place here. Suppose here. So you said your potassium is going on. When it is going, it has to come inside again, na? Because it has to go out again every cycle. So this in this phase 4, there is a active pump where sodium goes out, which has come here inside, and potassium come in. So this is known as 3 sodium out and 2 potassium inside. So this is maintaining the electronegativity, and one more, there are only potassium channel. From here the potassium is coming inside. So potassium is coming with the exchange of sodium, and only potassium channel from where this thing comes, and this will maintain the electronegativity, and this maintain the resting membrane potential of 0.90 millivolt. Now this is depolarization and repolarization. This is action potential is over. How ECG waves are related to this, I will explain you. We were cardiac myocyte. See, this is phase 4, this is phase 0. When there is a depolarization, little like this. So this phase 0 is coincide with the QRS complex. So if I draw like this, this plateau where the phase 1, when there is a, this is 20 millivolt and this is 0 millivolt, it comes with the J point. J point is a J point is a junction. J means junction. It is a end of depolarization, start of repolarization. So this is J point. So this is, and this is ST segment. This is ST segment on ECG. That what is ST segment will come, I will tell you. But why action potential is important at every part? Because this plateau phase is ST segment, and usually if you see, this is QRS, this is J point. So this is phase 0, this is phase 1, and this is ST segment where it is also flat. See this, and when this comes down, when potassium goes out and resting, it comes to the resting membrane potential of minus millivolt, it comes as a T wave. So here there is a T wave, and next suppose, so this is, so this phase 4, this is TQ segment, not TP, but it is TQ segment. So phase 0, when there is depolarization, this is QRS, J point, ST segment, T wave, and this is TQ segment, and TQ, and again this will start, again new cycle will start from here, QRS. So next action potential will start from here. Understood? Okay.